Lesson 4. Creating Professional User Interfaces. In this lesson, we will cover style guidelines, prototyping, customizing, documenting, initialization, and testing of the user interface. LabVIEW provides 4 different front panel object styles. It is best practice to use System or Silver controls for your top-level VIs and Modern for sub-VIs. Classic controls are useful for building a user interface on a low-color display. To keep a uniform look and feel to your application, limit VIs to one of the 3 standard fonts. Be aware that fonts can vary by platform. Don't overcomplicate or clutter your user interface. Keep important controls in prominent positions and keep inputs on the left and outputs on the right. In this example, the colors are distracting. The grouping of the controls makes poor use of the space, and the components are not clearly separated. In this example, each set of components is separated by lines, the controls have been reordered for clarity, and the dial has been swapped out for a more space-efficient slider. When sizing your user interface, keep it as small as possible without crowding controls. Consider launching the panel in a consistent location. The top left or center of the screen are good options. This can be configured from the VI Properties dialog box or performed programmatically through VI Server. When creating a sub-VI, be sure to implement a meaningful icon. Keep a uniform icon style for all related VIs. Enclose the icon with a border to make sure the sub-VI is visible on the block diagram, and apply an icon template when using project libraries. Use appropriate connector panes for your sub-VIs. It is generally not advisable to go beyond the 4x2x2x4 pattern. If this does not provide enough terminals, use clusters to group controls together. Keep your inputs on the left and outputs on the right, references on the top, and arrow wires on the bottom. Use the required, recommended, and optional settings for every terminal. Aim for similar arrangements between the front panel and connector pane layouts. The connector pane and icon for a VI should clearly show the functionality and how to wire it. Note that the message queue and message here are required, so the VI will break if these are not wired. The message queue input is also wired out so that other VIs may use it without splitting the wire before. Here are some recommendations for if you will be localizing your application. Leave extra room for text to be translated. Allow for about 30% growth in small strings and 15% growth in long sentences. Avoid hard-coding strings into the block diagram. Instead, move string constants to hidden controls or global variables. This will allow you to localize text by using the VI strings import method. Avoid using images that include text. If referencing controls by name, don't localize the label and instead make use of the caption. A user interface prototype is a non-functioning software implementation that provides an overview of the application, focusing on the user experience. UI prototypes can be useful to review with customers to get their buy-in early on in the development process. Be sure to explain that it is a prototype and not the final application. Avoid spending too much time creating the prototype.
In the sprint planning meeting for this iteration, the product owner chose to implement the user interface. After discussing this user story with the team, you identify the development tasks that you must complete. When you are done with this development sprint, you should have a front panel that resembles this diagram from the requirements document. Here is the user interface prototype that you're going to develop. When we run the VI, note that each button click takes us to a different case of our boiler controller loop. The one-button dialogues that we see here represent the functionality that we are eventually going to implement. For now, they're just serving as placeholders. Note that we have replaced the stop button that we were using earlier with an emergency stop. That's to help us differentiate between when we're just stopping the boiler versus when we're shutting down the entire application. In this exercise, you will create the front panel and implement one-button dialogues that display different messages depending on which button you click on the user interface. You will also update the message handling loop to interact with these front panel elements. Now let's take a look at the solution to exercise 4-1. When we open up main.vi and look at the block diagram, let's first look at the initialized case of the message handling loop. We've updated this case to reflect the front panel that we've created. First, we see that we're obtaining references to a variety of controls on the front panel and writing those references into our data cluster. We're also setting values for the fuel control valve control and the status indicator, and writing those values into the data cluster. Once we've finished writing data to the data cluster, we then send an update display message to this same loop. So that will take us to the update display case. And when we look at this case, we are extracting various indicator data from this data cluster and writing it to our controls and indicators. So it's important to note that within this application, there will be many different places where we try to write or set values for these controls and for these indicators. But this is the only location where those values that we set are actually written to those controls and indicators. Now let's take a look at how the various user button clicks are going to execute throughout this code. So say the user clicks on the reset value change event, which if we look at the different cases that we've implemented here, we're going to have very similar cases for each of those control events. But going back to reset, when they click reset, we're going to send a reset message down to our message handling loop. Within the message handling loop, we go to reset, and it's going to send a reset lockout message to our boiler controller. So when we go down to our boiler controller and see what does the reset lockout message do, we see that here we're just using a one-button dialog to display a message back to the user to prove that we in fact reached this part of our code. Eventually, when we're ready to implement the reset lockout functionality, we'll come back to this case and this is where we'll implement it and we'll get rid of this one-button dialog. Now we can see that for the various cases here, we see cases that correspond to different button clicks. So pre-purge, same kind of thing. These cases are all going to look very similar to each other. When the user clicks on a button on the user interface, the event handling loop sends a message to the message handling loop, which then sends a message to the boiler controller. The one-button dialogues within the boiler controller prove that the architecture is passing the correct messages to the correct loops. You will remove these dialogues as you implement boiler functionality. The dialogues for a code that you haven't implemented yet will prove that other functionality has not been broken by the code that you do implement.
Custom runtime menus. LabVIEW allows you to customize the runtime menu by selecting Edit, Runtime Menu. This creates a .rtm file that you can edit to create a runtime menu. Runtime menu events are processed by the event structure. Splitter panes allow you to divide up front panels into different sections. Effectively, what a splitter bar does is split the pane of the front panel window into two. This means that you can effectively have two independent windows in the same front panel. In this example, we have two splitter bars that are dividing the front panel up into three sections. The graph in the bottom right panel has the set object to scale with pane selected, as shown here. This means that when I run it and resize the window, the graph will dynamically resize. You can also add scroll bars to each pane individually, as shown here. This allows you to divide the sections of your front panel up into logical components. You can also add scroll bars to each pane individually, as shown here. Subpanels allow you to display another VI's front panel in your front panel. In this example, we have 3 VIs that are running continually, and we are swapping out their front panel dynamically. Here we have the sine graph being displayed in the subpanel. Changing the enum on the bottom allows us to change the currently running VI. One thing to note is that these VIs are all running simultaneously. Take note of the random number chart indicator. It's around 300 right now. Swapping back to the sine wave, and then back to the random number chart, we see it is still increased. Let's have a look at how this works. The code for this is relatively simple. It involves opening a reference to the VI, and then using property nodes to insert or remove a VI from the subpanel. Our event structure is very simple and only has 2 cases. The VI to display value change event removes the currently running VI from the subpanel and inserts the selected VI. The VIs continue to execute even though their front panel is removed from the subpanel. The stop event aborts all of the VIs, closes their references, and exits the loop. Tab controls have many property nodes and invoke methods that allow you to customize them programmatically. Spend a few minutes exploring this example. There are several reasons to use key navigation. In some environments, a keyboard may be the only available input device. Key navigation also adds convenience to your VI by providing standard functionality to common controls, such as escape to cancel out of a dialog or enter to confirm. If users will be tabbing through controls, be sure to set the tabbing order from top left to bottom right and to ignore hidden controls. Customizing the window appearance for your VIs allows you to change the way they look at runtime. Top-level application window hides the LabVIEW toolbar with the Run and Abort buttons. It does not allow resizing and shows the front panel. The dialog box preset prevents user interaction with other windows and stays on top. It hides the menu bar, scroll bar, toolbar, and does not allow the user to close the window. You can further customize any of these configurations by selecting Customize. LabVIEW provides many tools that allow you to create documentation for your users. Using these tools effectively can vastly improve the user experience of your application. Labels, captions, and context help can all be used to provide documentation to your users. Use descriptive names for controls and indicators, and if the default value is essential information, include it in parentheses. Captions can also be used to provide additional information to the user without taking up space on the block diagram. Adding a description for controls and indicators will allow you to create documentation for the Context Help window. This is a good place to include documentation on the functionality of the control, the default value, and the valid range for user input. Adding tip strips to your controls also increases the user-friendliness of your application. Adding a description to the VI properties allows you to include help text that will show up in the context window when looking at your VI. You can also include a path to a help file that will show up as the detailed help link in the context help window. Printing the VI documentation can be a way to create a hard copy of all of the documentation in your application. This can be used as a starting point to customize your help documentation to meet your application's needs. Adding a help file to the VI documentation creates a link to the detailed help in the context help window. These help files are HTML documents and can be created by printing the VI and then customizing it as needed.
After presenting the user interface prototype, the customer representative re-emphasized the desire for documentation in the user interface to improve its usability. They also made several cosmetic suggestions for the user interface. The product owner documented the user interface feedback for implementation in a future sprint iteration. As a result of the customer's feedback, the product owner has prioritized implementing the documentation user story. After discussing this user story with the team, you identify the development tasks that the team must complete. Now let's take a look at the user documentation that you're going to create for the Boiler Controller project. First, let's expand project documentation. Then we'll click on Boiler Controller and launch main.html. This file contains documentation for both the top-level VI as well as for its controls and indicators. Now let's take a look at main.vi. When we hover over the icon for this VI, we can see the context help window populates with information about this VI. We can also click Detailed Help and view the HTML file that we just looked at a moment ago. Additionally, when we hover over each control and indicator, we can see that the context help updates with information about that control or that indicator. When we run the VI, we can also, by hovering over each control, we can see tip strips for how to use that control or what functionality is associated with that control or indicator. Let's take a look at the solution to exercise 4-2. To create documentation for the top-level VI, we can right-click on the icon and select VI Properties. From here, we can select the drop-down and click Documentation. Here is where we create the description for the VI that's going to appear in the context help when we hover over that icon. In addition, we can specify the path to the HTML file that we want to launch when the user clicks on Detailed Help. In addition to creating documentation for the VI, we can also create documentation for each control and indicator on our front panel. To do this, you can right-click on the control or indicator and select Properties. From here you select the Documentation tab, and here you can create whatever documentation you like for the description, and that's what's going to appear in the Context Help window. Additionally, you can create information that you want to appear when the user just hovers over the control. Once you've created documentation for each control and indicator and created whatever documentation you want for the top-level VI, now is when you can go through and create that HTML file that we looked at. To do that, you'll select File, Print. Here we're going to leave it as main.vi because we're really only interested in creating documentation for the top-level user interface VI. So here we're specifying that we want to create VI documentation. And here's where we can customize what information we want to appear in this HTML file that we create. Here we're specifying that we want to include the top-level VI description, we want to show an image of the front panel, and we want to include descriptions for each control and indicator. Then we specify what type of files we want to create. So here we specify an HTML file, click Next, and specify for the images that we create what format we want to use. I'll just leave it as it is. And at this point, now we can click Save, and that will create the HTML file, which we can then add to our project. The help file that you create in this exercise is primarily for the end user of the application. How might things be different if you were creating documentation for other developers? When creating a help file for other developers, you might want to include documentation for project libraries and the entire application hierarchy. The process for creating documentation for other developers is going to be very similar to the process we used for creating user documentation. We'll go to File, Print, but now instead of selecting just main VI and only creating documentation for the top-level VI, we'll instead select multiple VIs. And here we can have several options. We can select a VI and just add the entire hierarchy for that VI, or we can navigate on disk and specify individual files that we want to add. In this case, I'm going to select Add VI Hierarchy. And then I'm going to select main.vi so that I'm going to include every VI and custom control that is part of this VI hierarchy. However, I do want to exclude VIs that are part of vi.lib. So now we can see all of the controls and all of the VIs that are part of main.vi. So we can click Next, and here we're back to some of the screens that we've already seen. We can specify that we want to create VI documentation, what type of information we want to include for each control and VI, and also what type of file we want to generate. So now when we click on Print or select to save, when we get to this screen, we'll now generate an HTML file that includes information about the top-level VI as well as every sub-VI and every custom control that it uses.
When your application starts, you want to know that it's in a known good state. This is initialization. Initialization can include setting the default value of controls, setting default directories or file paths, and setting the enabled or disabled state of controls. There are two common ways to initialize a VI. The first is with a sequence structure outside of the main loops. The benefits to this are that it is quick and easy, and it is easy to see your initial state at a glance. However, if your code needs to be reinitialized at runtime, you have to duplicate code to add that into the message handling loop or state machine. Instead of having initialization occur outside of the loop, you can create an initialized case that can be called whenever needed. This state will include the same functionality as the sequence structure outside of the code, but it has the advantage of being able to be called repeatedly. Previously, we talked about initialization using constants and local variables. This works well if your application only has a single set of initialization parameters. However, if you're going to have multiple settings that vary based upon deployments, it's a good idea to initialize from a file. Initialization files can include things like user preferences and hardware settings that may vary from station to station. Two recommended file formats are CSV and INI. Take a minute to explore both of these options.
In the sprint planning meeting for this iteration, the product owner chose to implement the initialization user story. After discussing this user story with the team, you decide to read the configuration settings from an INI file. The requirements document indicates that the fuel control valve should be limited to values between 10 and 75%. Since this may vary from boiler to boiler, those values should be read from a configuration file instead of written as constants on the block diagram. Your team identifies the development tasks that you must complete to satisfy the initialization user story. Let's take a look at the initialization functionality that we're going to implement as part of this exercise. First, let's look at the initialization file itself. This file is divided into three sections, one for the message handling loop, one for the controller loop, and one for the boiler loop. Within the message handling loop, we can see that we have values specified for the minimum value of the fuel control valve and the maximum value of the fuel control valve. Now let's take a look at the main.vi. So here we can see that before running the VI, the minimum value is set to 0, the maximum value is set to 100. If I run the VI and select the initialization file that we're going to load, now this can be valuable in that if we have different initialization files for different boilers, here's where you can specify the right one for the boiler you happen to be running in this instance. So I'll select the initialization file, and now we see that the values for the maximum and minimum for fuel control valve have been changed to be 10 to 75, as indicated in our initialization file. In this exercise, you will update the initialized case of the message handling loop to read user interface constants from a configuration file. Now let's take a look at the solution to exercise 4-3. Within the project, let's look at support VIs, configuration, and here we can see the VIs that we're going to use to create the configuration file and then read data from that file. We've also added boiler init.ini to this project. Now let's open main.vi. And let's look at boiler system open. So here we've added the read configuration data VI, which then provides information from that ini file that we can then use in our message handling loop for initialization. When we look at this sub-VI, you can see that we're navigating to the specific initialization file to open. Then we open the file, and then we read specific MHL configuration data from that file. Then we close the file. Let's take a look at the function that's actually going to read those constants from the initialization file. Here we have our two read key functions, where we're going to read from a specific section specific values. Then we pass those data out and into the MHL configuration output of this VI. In this case, you can see that we're passing out the fuel control valve minimum and maximum values. So now let's take a look at the initialized case of our message handling loop. So you note that we've made some changes here. We've basically taken a lot of the initialization functionality and placed it into initializePanel.vi. The reason for this is that our diagram here was starting to get a little cluttered. So it was getting a little hard to navigate and there's a lot going on. Plus we wanted to add some additional functionality with the configuration and initialization, so it was just getting a little cluttered. If we look inside of this VI, here's where we can see that we take the message handling loop configuration input, read the maximum and minimum values, and set those as the maximum and minimum properties for the scale of the fuel control valve. You can create multiple ini files for different boilers. From the application's perspective, there is no code difference as long as the sections and keys are the same for all ini files. You could just specify a different ini file and the software will use the new values. This is much easier than updating string constants all over your block diagrams. ini files are very scalable and it is very easy to add new sections and new keys.
It's important to gather feedback from your users to make sure that your application is meeting their needs. The goal of usability testing is to make sure that the program is not only functional, but usable.
Remember when you created the user interface prototype? Well, the customer representative has finally come back with usability feedback from the end users. Let's take a look at the usability improvements that you're going to make to this application. When we open main VI, note that we've reorganized the front panel to be a little bit more usable. Most of our controls are on the left, our indicators are all on the right, and the emergency stop button is large and prominent in the lower right-hand corner. When we run the VI, we are now launching the boiler user interface in addition to our boiler controller interface. And note that these windows are customized now to remove functionality that we don't want the end user to have. For example, the boiler UI, we've removed the ability to close and minimize or resize this window. We've also set up so that there's no toolbar or runtime menu. Within our boiler controller, we've removed some functionality, like we no longer allow them to resize the window, and we've also removed the toolbar. But we still have a menu, but this is a runtime menu that we have custom defined for this application, wherein we can select that we want to launch the help file that we looked at earlier, or we can go through and use File and then use this option to create the emergency stop. In this exercise, you will modify the user interface to make it more usable for the intended end users. Let's take a look at the solution to exercise 4-4. In this exercise, we modified the main VI so that the front panel would be a little bit more usable and a little bit more organized. In addition to modifying the front panel, we also modified the window so that it would have more of a dialog top-level window appearance. To do that, we right-clicked and select VI Properties, and then from the drop-down we go to Window Appearance. And here we can specify that we want the window appear as a top-level application window. If we're curious about what that means, we can select Customize and see the options that go along with that configuration. In addition to customizing that appearance, we also created a custom runtime menu. So here we can select Edit, Runtime Menu, and here we can see the runtime menu that we defined for this exercise. So here we have File, and then under File we'll have an emergency stop, and then we also have a button that will launch the help for this VI. Here's where you configure it, and then up here under the preview you can see what it would actually look like at runtime. So to handle those clicks, we'll go back to our event handling loop, and here we can see menu selection. So this is actually looking at the runtime menu that we've defined, reading the tags based on what the user clicked, and then sending messages to our message handling loop accordingly. So we're repeating the exact same functionality for when the user goes to the menu and selects emergency stop that we would have seen if they clicked a button on the user interface for emergency stop. If there are any other menu clicks, then we have just a default case just in case something happens, and this is just a way of handling any errors that might occur. So in addition to modifying the main VI, we also modified boiler.vi so that when it's loaded into memory, it's going to appear and have the appearance of a dialog window. To do that, again, we went to VI Properties, Window Appearance, and we started with the dialog configuration. And in general, I recommend selecting one of these default configurations and then customizing from there. Once you start customizing, it then takes you to the custom option. But we selected dialog, clicked Customize, and then we configured how we wanted the window to appear. And specifically, we indicated that we wanted the front panel to show when the VI was called. And then after the VI is closed, then we close the front panel after the VI is finished executing.
You have completed this lesson. Here's a summary of what we covered.